For decades, we've treated them as two separate worlds. The IT network, your world of data, cloud, and email, and the OT network, the world of physical processes, power grids, water treatment plants, and manufacturing floors. We built a wall between them, an air gap, and we believed it would keep our critical infrastructure safe. That belief is now dangerously wrong. Here is the uncomfortable truth. 75% of all attacks on operational technology begin as breaches in the IT network. This isn't a theory, it's a statistic that defines the single biggest threat to our critical infrastructure today. Nation-state actors like China's Volt Typhoon aren't trying to break into your power plants directly. They're walking in through the front door of your IT network. I'm Olayemi Oyenye, the Practical Security Architect, and today we are dissecting the 75% problem. By the end of this video, you will understand why the IT-OT divide is a myth and how to build a unified defense before it's too late. The concept of the air gap is simple. If two networks are not physically connected, nothing can cross between them. It's a powerful idea, but in 2025, it's a fantasy. The reality is that for operational efficiency, data analysis, and remote maintenance, these two worlds are more connected than ever. The sneakernet. A technician carries a laptop or a USB drive from the IT network to the OT network to perform an update. That's how Stuxnet famously breached the air-gapped Iranian nuclear facility over a decade ago. Remote access. A third-party vendor needs to service a piece of industrial equipment, so they are granted remote access from their own network, creating a direct bridge. Shared services. Both networks might rely on the same Active Directory for authentication, creating a single point of failure. Research shows that 23% of organizations with air-gapped systems still experience security incidents. The wall is an illusion. For a determined attacker, it's not a barrier, it's just a speed bump. So how does this actually happen? The attack path is remarkably consistent and follows a clear 5-step process. 1. IT compromise. It starts with a standard IT attack, a phishing email, a stolen password, or an unpatched VPN. The attacker gains a foothold on a standard corporate workstation. 2. Lateral movement. From that workstation, the attacker moves silently across the IT network, escalating privileges and looking for a bridge to the OT world. 3. Crossing the divide. They find their target, a server that has access to both networks, a shared credential, or a vulnerable remote access portal. They use this to pivot from the IT environment into the OT environment. 4. OT discovery and movement. Once inside the OT network, they are in a completely different world. It's a flat, unmonitored environment with legacy systems that haven't been patched in years. They move freely, identifying the critical control systems, the PLCs, the HMIs, the SCADA servers. 5. Impact. They execute their final command. This could be deploying ransomware that shuts down a manufacturing line, manipulating a control system to damage equipment, or disrupting a critical service like power or water. This is not theoretical. This is the playbook used by groups like Volt Typhoon, who are actively pre-positioning themselves inside US critical infrastructure, waiting for the command to cause disruption. When this attack path succeeds, the consequences are not just data loss, they are physical and potentially catastrophic. In the manufacturing sector, attacks are up 87% year over year, and 75% of them cause operational disruption. In the energy and utilities sector, ransomware attacks surged 80%. Globally, there are over 145,000 industrial control systems directly exposed to the internet right now. This is why we're seeing a massive organizational shift. In 2022, only 16% of companies had OT security under the CISO. By 2025, that number has jumped to 52%, with 80% planning to follow. The boardroom has finally realized that you cannot separate IT risk from OT risk. They are two sides of the same coin, and the total economic risk of OT cyber incidents is estimated to exceed $300 billion. So how do we solve the 75% problem? We have to tear down the organizational silos and build a unified security architecture. This is where the principles of CSMA 3.0 become essential. 1. Unified visibility. Your cybersecurity mesh architecture must extend into the OT environment. The infrastructure management layer needs to provide a single comprehensive inventory of all assets, IT and OT. You need to see the connections between them to understand the potential attack paths. 2. Zero Trust segmentation. The IT-OT boundary must be protected by a zero trust gateway. All traffic attempting to cross must be authenticated, authorized, and inspected. Assume any connection is hostile until proven otherwise. 3. Centralized policy. You need a single centralized policy, posture, and playbook management layer that governs both environments. The rules for accessing a critical server should be just as strict whether you are coming from the IT network or the OT network. 4. Correlated threat detection. Your security, analytics, and intelligence layer must ingest telemetry from both IT and OT security tools. It needs to be able to correlate a phishing alert in the IT network with anomalous behavior on a PLC in the OT network. This is how you detect the attack path in progress. The 75% problem is the single most urgent challenge facing security architects today. The safety of our critical infrastructure depends on our ability to solve it. The era of treating IT and OT as separate domains is over. Your first step is to challenge the myth of the air gap in your own organization. Map every single connection point between your IT and OT networks. You cannot defend a border you do not understand. By embracing a unified, mesh-based approach, you can turn the 75% problem into a 75% reduction in your risk. It's time to build the bridge before the attackers burn it down. I'm Olayemi Oyeniyi, and I'll see you in the next video.